Large healthcare organizations don't struggle with interoperability because they lack standards. They struggle because clinical data lives across many systems, each exposing patient access in its own way. In the next few minutes, I'll walk you through a real-world, inspired approach that modernizes interoperability without disrupting systems already in production. This use case comes from a large healthcare institution operating with multiple EHR platforms. Each system exposed patients' access services independently. The result was fragmented data access, duplicated logic, and most importantly, no shared semantics. Every application had to understand identifiers, patient concepts, and rules on its own. The organization didn't want a complete rebuild. They needed to centralize clinical data access without breaking applications already in production. That's where the idea of an operational data layer came in. But a traditional ODL would have meant redefining data structures and semantics from scratch. At that moment, it hit us. Instead of inventing new semantics, why not reuse the ones the industry already agrees on? By designing the ODL data model as a FHIR first, FHIR becomes the common language for core clinical concepts. Entities such as patient and encounter reuse standard FHIR definitions instead of custom schemas. This avoids reinventing the wheel and immediately aligns the platform with industry standards. So the real opportunity was a hybrid approach. What did we propose then? Use FHIR definitions as the foundation for core entities and extend FHIR only where necessary to support existing non-standard fields. This way, we ensure balance between interoperability and operational continuity. This hybrid approach is reflected directly in the data model. Each clinical entity, like a patient or an encounter, is stored as one MongoDB document with 3 logical layers. First, the resource block. This contains the canonical FHIR resource, untouched and standard-based. If you query through a FHIR API, this is exactly what gets returned. Second, the application block. This is where operational reality lives. Internal case numbers, practitioner codes, workflow flags, fields that do not exist in base FHIR but are critical for day-to-day systems. And third, the search block. This contains denormalized index fields optimized for fast operational queries. That separation gives us performance without sacrificing interoperability. A pure FHIR server is often too rigid for operational workloads. A fully custom schema is fast but loses standard alignment. The hybrid ODL sits in the middle. FHIR where it matters, but custom where it's required. Now, how do we expose this data? Well, we use a dual API strategy. Custom application APIs serve existing integrations with optimized performance. At the same time, FHIR APIs run over the exact same dataset. There's no data duplication and, more importantly, no ETL pipelines. This is not a fully compliant FHIR server, and that's intentional. The goal is to reduce friction today while creating a clean path to a future FHIR facade without re-engineering the data layer. Now, let's take a look at the demo itself, shall we? Once you access it, you are greeted with the main explanation tab, which includes all the relevant information that one may need to understand and operate the demo. Recommended workflow, tab-specific explanations, and even step-by-step instructions to make the most of the usage of this service. When we are done with it, we can easily navigate to the main screen through the button on the right upper corner. First, the mappings view, in which we can explore the mapping strategy followed by this approach and learn about every field and its specifications in the data model. Then, the synthetic data creator, where we can create and erase as many clinical entities as we want. By simply adjusting the main parameters, synthetic clinical data is auto-generated and stored in the dataset with just one click. To analyze and search the data, we can use the Data Viewer tab. Here, we'll find a complete display of all the different data entries. To see our custom API endpoints in action, we will use the Customer API Tester, a specifically designed space to test every custom endpoint, making it the perfect tool to understand how your operational queries would work with real data. On the other hand, if FHIR standard queries are what you're trying to test, the FHIR API tester is perfect for you. Preset queries alongside specific search parameter definitions await for you to try the full standard version of this data model. And finally, what would all this be without the proper documentation? Feel free to explore every aspect of the different APIs in our documentation tab. As we have already seen in practice, users can explore mappings, generate synthetic FHIR data, and much more, all from the same unified service. And this isn't theoretical. Everything you see here can be built using standard tools and patterns, following this architectural approach. At the center, we use MongoDB Atlas, storing the hybrid FHIR documents. On top sits the dual API layer, exposing both applications, APIs, and FHIR APIs. All that allows us to create the service you just witnessed, a unified way of creating, analyzing, and using this new hybrid ODL approach. The expectation is that interoperability requires a clean break from the past. But the reality is that most organizations need to modernize incrementally. With the right approach, you can improve performance, accelerate interoperability, and future-proof your platform. All that without breaking what already works. And that approach is the hybrid FHIR ODL.